We are starting Unit 6, Systems of Equations. So the first few slides are just reminders. Make sure you take care of notes even when you're absent. Update your digital interactive notebook. You will be submitting screenshots of your notes. We didn't do that last one, but we might be doing that this time. Let's look at slide 5. This is the first slide that we will be writing on or typing on. So let me zoom in. So systems of equations are, we need to add a text box there. Oh, is there? Okay. Systems of equations. A set of two or more linear equations in the same variables. We're going to learn several ways to solve systems of equations. So a system of equations would be basically two equations. So like y equals 4x plus 1 and y equals 1/2 x minus 3. You are going to find the solution is graphically the point where the two lines intersect. Algebraically, the point that makes both equations true. So let's look at the types of solutions that we could have. So if they intersect, we have one solution. We have a point. And we will write the solution as a coordinate x, y. If we have parallel lines, they will never intersect. Therefore, you have no solution. So you can write with a 0 with a slash through it. If it is the exact same line, they're intersecting at every single point. So we can write the symbol for infinity, or we can write infinitely many solutions. Let's write something down in our journal. So open up your journal. So the instructions for this are tell whether the ordered pair is a solution of the system of equations. So our first one is 2, 5. We're going to see whether that is a solution or not. And here is our system, x plus y equals 7. And 2x minus 3y equals negative 11. So the solution, if it is a solution, it'll make both equations true. So that means I'm going to plug in a 2 and a 5 and see if it's true. So I'm going to plug it in for the first equation and the second. It has to be true for both equations. So 2 plus 5 equals 7, right? Is that true? Okay, so I'm going to put a little check mark by it. And we have to do the other one too. 2 times 2 minus 3 times 5 equals negative 11. And you see if that's true. 2 times 2 is 4, minus 15. Keep change. That equals negative 11. So yes, it's true. Two, 5 is the solution, or is a solution. Or we can just write yes. Okay, the next one is going to be check this point 1, 4. With this system, y equals 3x plus 1, and y equals negative x plus 5. Okay, so this is x, this is y. So on the first one, it's 4 equals 3 times 1 plus 1. Is that true? Yep. So then the next one, y is 4 equals negative 1 plus 5. Okay, so this is, yes, it's a solution. One last one. Negative 1, negative 5, and y equals negative x plus 2, and y equals 3x minus 2. So this would be negative 5 equals negative 1 plus 2. Negative would become plus, so it's negative 5 equals 1 plus 2. Is that true? No. So do we really need to check the other one? No. You can. It would just be negative 5 equals 3 times the negative 1 minus 2.
No.
Negative 5 equals negative 3 minus 2. That is true. But just because this one is not a solution, that makes it where that is not a system. I mean, a solution to the system. Because remember, we're finding where they intersect. So this line goes through that point, but this line does not. So it can't be a solution because this line doesn't even go through that point. So this is no. Negative 1, negative 5 is not a solution. Hello. Hey. Yes, it has. Yeah, not a charger. It's her whole Chromebook is not working. Yeah. I'm recording. Is not a solution. All right. That's just how you can check if it's a solution or not. So anytime we want to check and see if it's a solution or not, we just plug in the X and Y values. All right, let's go to our next part. All right, solving systems steps. All right, so step 1. Graph each equation in the same coordinate plane. So on the same graph. You can graph more than one linear equation on a graph. So that's what we're going to do. Step 2 is estimate the point of intersection. In step 3, check the point from step 2 by substituting X and Y in each linear equation. So let's go ahead and graph this. Let's see, do we have any lines? Yeah, we have a line here that we can copy and paste. So we don't have to make new lines. If you don't want to, you can just use that one. So let's graph the first one. Go ahead and plot points, and that'll help you graph it easier on here. I'm going to grab 2 points. Okay, so y equals x minus 3. So we're going to graph the y-intercept at -3, and then go up 1 over 1. Up 1 over 1. Up 1 over 1. So just have a couple of points. And now use your line. There we go. Okay, the next one, our y-intercept is at -1. Now we're going to go down 1 over 1, down 1 over 1, down 1 over 1. I'm going to copy and paste this line. Control-C, Control-V. Okay. So do you see where they intersect? Okay, let's make that point. Well, now that I have put it over the top, I can send it back. Options, order, send it back. That way I can grab that point. And I'm going to make that point red. That's my point of intersection. So let's estimate where that's at. Where is that point at? 1, -2. And now we are going to check the point from our step 2, which is this 1, -2, by substituting in x and y in each of the linear equation. So I'm going to go back to, what slide are we on? Slide 5. Back to my digital or my composition book, but let me write down the point first and the equations on my composition book. And we are going to check them. This is x, this is y. So it'll be -2 equals 1 minus 3. Is that true? Yep. And then -2 equals -1 minus 1. And that is true too. So that means we did it correctly. So we can put 1, -2 is the solution. All right, so we are done with that. Let's go to the next slide. Okay, we have y equals 2 and y equals -1/3 x plus 4. See if I have any points over here. Yeah, I got some points. I'm going to grab these points and that line, copy and paste, and maybe I can drag it over here. Yeah. Okay, so y equals 2. What is that going to look like? What kind of line is that? Does it have a slope? Or what is the slope, I guess I should say. Y equals 2? The y-intercept is at 2. And we have a slope of 0. So it's going to be a horizontal line. Remember slope, dude? Make it as horizontal as you can get it. Okay. And then the next one, -1/3 x plus 4. So we have 4, and then -1/3. So down 1/3. Down 1/3. See if I can get it to go through those points. Okay. Then make the point of intersection red. Okay, so what is that coordinate? So that would be, is it 6, 2? Over 6 up 2. So then we need to check it. So y equals 2. Does the y value equal 2? Yep. And this is saying we can use our calculator to check it. Instead of working it out by hand, we can use our calculator to check it. It might be easy just to check it by plugging it in, or you can use the calculator. So negative, so y is 2. So negative, did you know that you can actually put this in? 2 and then equals, I think there's an equals. 2 equals, let me see, I think it's under math or catalog. No, not. There is a way to, oh, it's second math? Okay, so second math, thank you. 2 equals negative 1/3 times x, which is 6, plus 4. If it's a 1, that means it's true. If it says 0, that means it's not true. So we did the calculator check. It was second math to get the equal sign on there. Calculator check, so get that little check mark over here, showing that we did check it. Okay, let's look at the next one. Y equals negative 3x minus 5 and y equals negative 3x. What do you notice about these two?
Their slope is the same.
Slope is the same. So what do we know about lines with slopes that are the same?
They're going to go
Same direction. Will they ever touch? No, they're parallel. But let's go ahead and graph them. So we have negative 5. Let's zoom in. Negative 5 as our y-intercept on the second one, or first one. And then down 3 over 1. Down 1, 2, 3 over 1. We could also go up 3 over 1. We need a line. And then the next one has a y-intercept of 0. And it's the same slope. Down 3 over 1. Down 3 over 1. Okay, so type of solution, if there is one, there is no solution. You can also do the 0 with the slash through it. I wonder if we have that on our symbols. I don't see it on the symbols.
It's on there, you just have to draw it, like in the little, where it says.
Oh, okay. Insert special characters. Like that. Nice. See, y'all teach me so much. All right, cool. So we can't do a calculator check because there is no solution to check. Let's go to slide 7 is more of the same, looks like. What do you see about slide 7? Slope's the same here, so will we have a solution?
No.
This one, slope same. Will we have a solution? Oh, hold on. Hold up. What do you notice about this one, though?
The y-intercepts are the same.
Y-intercepts and the slopes are the same. So then what will we have?
Infinitely many.
Yeah, infinitely many. Okay. Because they are the same exact line. The other one we didn't do, we already know that they're not. I'll let you do that on your own. Okay, let's look at the next slide. So you'll have to finish slide 7 on your own. Let's look at the next slide. What are you going to have to do on these? Yep, we're going to have to solve for y first. So I'm going to go ahead and pause and give you time to work on this and find your solutions and check them. Your assignment is to finish 5 through 8, slides 5 through 8. There'll be an assignment tomorrow.